This video is made to go along with the notes labeled 1.3 Functions and Their Graphs. If you do not have these notes in front of you, it would be a good idea to pause this video now, get a printout, or at the very least pull those notes up so that you can follow along as we talk about the notes and do some examples. A relation is something that shows a mathematical relationship between two quantities. We don't really talk much about relations except for the fact that a function is a special type of relation. So a function is a relation that has a function is a relation. So it is a mathematical relationship between two quantities where each input value is associated with exactly one output value. So each input is associated with exactly one output value. Now, we usually refer to these input values as x's, though there's nothing magical about x, and occasionally you'll see a t or a q or some other value associated with it, but usually we think of the input as x and the output as y. So a function is a relationship such that each x is associated with exactly one y. An example that I use frequently is your class schedule. So each one of you has a class schedule. You are told that you need to be at your English class at 12 o'clock. Then you have your social studies class at 2 o'clock. You all have a math class at 5:15. So long as each one of you is told to be only one place at a time, your college schedule is functional. It is a function. It relates you to where you're supposed to be. But now assume that you get your college schedule, and on the schedule it says that you need to be in math class and in English class at 5:15. So for the one input that is you, there are two different associated outputs. That schedule is no longer functional. So that relationship no longer associates each input with exactly one output, and therefore it is not a function. There are many ways to express the relationship between two quantities. You can have a basic written description. You can have a set of ordered pairs, a diagram, a table of values, a graph in the xy plane. Any one of these can be used to express a relationship or a function. So the question is, how do you determine whether or not a relation is a function? So in example 1 on our notes, we see the following relation, and we are asked to determine whether or not this relation is a function. So in the notes, 1 goes to A, 2 goes to B, 3 goes to B, and 4 goes to C. So this is our input, this is our output. Is this a function? Does each element of our input go to exactly one element of the output? And the answer to that is yes. Yes, it does. So this is a function. Now notice we can have and do have two different inputs going to the same output. That's okay. Again, think to the example I gave you about your class schedule. Everyone listening to this video right now is in the same math class. All of your inputs lead you to the same output at 5:15. It is still a function because each individual input has only one output. those outputs can in fact be the same. In the second example on the page, however, we see the arrow configuration is a little bit different. Oops, I put output over my input. I'm going to erase that and put input. And then over here we've got output. All right, so as we come, we see that 1 goes to A, 1 also goes to B, 2 goes to C, 3 goes to C, 4 goes to C. So all of that is okay. Having 2, 3, and 4 all go to that exact same output value is not a problem. This is not a function because this input value of 1 has 2 different output values associated with it. So because of this 1 having 2 outputs, this is not a function. Next, we see a set of ordered pairs. Now, you can take these ordered pairs and just directly see, all right, 3 goes to 6, no problem. 2 goes to 1, negative 4 goes to 0. But then 3 goes to 8. So in 2 different places, we have this 3. We have 3 going to 6, and we have 3 going to 8. If you wanted, you could make one of those function mappings like we saw in the other example yourself, and we say, all right, what are the different elements of my input? And we're going to learn in a couple minutes that that input set is called my domain. So we've got negative 4, 2, and 3. And notice, even though 3 shows up twice, I'm only going to write each element down a single time. Then in my output, I have a 6, a 1, a 0, and an 8. I take my lines and I say, all right, so 3 is going to go to 6, 2 is going to go to 1, negative 4 is going to go to 0, no problems yet, but then this second 3, 8 point, that's where my problem shows up. Suddenly I've got 2 different arrows stemming from the same input value, so this set of ordered pairs is not functional. It is not a function. We have another set of ordered pairs. So here we will individually list each element of my input set, and like I said, that is called the domain, which we will be talking about officially in just a second. But that's going to be negative 2, negative 1, 0, and 1. And then my output values, which we will know in a minute, is called the range of values. That's going to be 5, 1, negative 3, 1. So again, very simply, I connect the inputs to their associated outputs. Negative 2 goes to 5. Negative 1 goes to 1. I did not mean to write 1 twice there, so I'm going to erase that second one. 0 goes to negative 3. And then 1 goes to 1. 2 different arrows go to the same output. That is okay with us. There is no problem. This is a function. And we can tell that it is a function because each one of my inputs only has a single arrow coming out of it. Each input has only one output. So yes, it is a function. In order to do math together as we move forward, we're going to have some common vocabulary. So as I alluded to, we do have specific names for our input and output sets. So the domain of a function, right, the set of all input values of all possible inputs is the domain of the function. All right? And this is what we usually associate with x. The set of all possible outputs is called the range of the function. And that is usually y. The inputs, x, those are also referred to as our independent variable. And independent because normally we put the x values in and we choose what we want to do there. And then we call the y, that is our dependent variable. Dependent because we usually find the y, and that y is found dependent upon what x value is put in. Whenever we analyze a function, the first thing that we want to do is look at the domain of the function. And so we need to ask ourselves the question, what is the domain of the function that I am looking for? And I am actually going to pick up on that in part 2 of this video because I'm going to run out of time. So